Alrighty, welcome back, boys and girls. It's your main math man, Miss Shank, coming to you live from Mayfield. In this video, we're closing out the week with our Fresh Friday warm-up. And at the very top, you want to make sure you can take the difference of these two squares first. So we're going to say 25 squared is minus 24 squared. Again, make sure you're not multiplying by 2, but you are raising it to the second power. So we say, alright, 25 squared is 625. So I can say, alright, this is going to be 625 minus whatever 24 squared is, which is 576. Again, take the difference of the squares. It's almost like we are solving for the missing leg in a right triangle. And so when we take the difference of these two numbers, again, I can type it in exactly how it looks in the Desmos calculator. I'd say, all right, this equals 49. If we were solving for a missing leg in a right triangle, we would then take the square root of both sides to solve for that missing leg value. But for right now, we're just evaluating this expression. So we get 49 for that amount. Then it says, for number 1, the diagram below shows Broadway Boulevard intersecting with Maple Street. Tulip Lane is perpendicular to Broadway Boulevard. The angles formed by these streets are numbered from 1 to 5. And you see the picture here again. It says these angles, we would label them as angle 1, angle 2, angle 3, angle 4, and angle 5. Then it says, list one pair of angles for each of the following and be able to explain how you know each angle pair is correct. So make sure you're seeing it like this. We can say, all right, well, for complementary angles, we know that they add up to 100, or no, let's back up. Complementary means they add up to 90 degrees. So we know that angle 3 and angle 4 are complementary angles because they add up to 90 degrees and they form a straight angle with angle 2. So let me highlight what I'm referring to. So I said, all right, angle 3. So I have angle 3 and angle 4. Again, you can see if they are complementary, I should be able to make a corner. Let's try this again. I should be able to make a corner out of these angles. Again, all that is saying is if we add them together, they should equal 90 degrees. And we know they equal 90 degrees because angle 2 is specifically and exactly 90 degrees, which is why it has that little box in the corner there. Also, you can see that since the angle 2 is 90 degrees, we know that we can form a straight angle along that Broadway Boulevard. So again, if you are able to form that straight line along that street, you know it would be 180 degrees. So we'd have, this is 90 plus 90 is 180 degrees. And speaking of 180 degrees, you have for supplementary angles, we know that angle 4 and angle 5 are supplementary angles because they add up to 180 degrees along Maple Street. So let me highlight what I'm referring to. So again, it's saying, all right, I have angle 4 and angle 5. And again, it goes along that Maple Street. And again, see how I'm able to draw that straight line. It has these two angles. Angle 5 is obtuse and angle 4 is acute. So one of them is going to be larger than 90 and the other is going to be smaller than 90. However, when they add up together, it is going to be 180 degrees, which is why I'm able to draw that straight line or that half circle. Then for the last one, it says vertical angles, and we can say this. So a little bit more detail, but we are able to understand these ideas. So it says we know that angle 1 and angle 4 are vertical angles. So let me go ahead and highlight those first. So I have angle 1 and angle 4 are vertical angles because they are opposite of each other. They share the same vertex and they both form a supplementary angle with angle 5. And like most people say, period. Alright, so make sure that you're seeing how this works. I said they are opposite of each other. How do we know what they are opposite of each other? Well, we can say, alright, I have the two lines that are formed to make the X, meaning that angle 4 and angle 1 are opposite of each other. Again, they share that same vertex, which is that point in the middle. And so then for the last part, they both form a supplementary angle with angle 5. And we know that from that previous question as well. We said that angle 4 and 5, again, I highlighted it like this. I said, okay, angle 4 and angle 5 form that straight line along Maple Street, and you can see that angle 1 and angle 5 along Broadway Boulevard form a straight line. So make sure you're seeing, again, along Broadway Boulevard, they form a straight line, meaning it is 180 degrees. So again, be able to prove that for yourself. Use the knowledge that you know based off of facts. Make sure your name's on it and turn it in.